Hi guys. Today we're going to talk about section 1.4, the tangent and velocity problems. Specifically, I'm going to be talking about velocity here. We'll talk about tangent in class. So let's say I ran 100 yards. How fast did I do it? Okay. Well, that's a question that can mean a lot of different things. It can mean how fast did I do on average over the whole 100 yards, or it could mean how about the first 50 yards or the second 25 yards, right? There's lots of different questions I can ask. How fast did I do different parts of that 100 yards? But there's another kind of question that can be asked. How fast was I going at the 25-yard point? At the split second in time when I passed that 25-yard marker, how fast was I moving? Right? This is like asking, how fast is your car going right now? You look down and you see the speedometer needle or the digital readout give you a number. What does that mean? That's the instantaneous velocity or instantaneous speed at a particular point, at a particular moment in time. And how we calculate that is an example of the kind of thing that we'll be doing for most of this semester of calculus. Okay. In general, you want to compute a velocity, it's change in position over change in time. Right? This is something that at least I memorized. Change in position over change in time, or displacement over change in time, or something like that. That's an average velocity. Over this amount of time, you moved a certain amount of distance. You divide distance over time, and that's your average velocity, or average speed. So if I wanted to answer the question, how fast did I move in the first 50 yards of my race, I would divide the change in position, that's 50 yards, over how long it took me. Ending time minus beginning time of that 50 yards. Same thing for if I want to know how fast was I moving over that second 25 yards on average. But that fails if I want to know my speed or velocity at a particular point, because there's no elapsed time, there's no elapsed distance, there's no from this point to this point, it's just right here. So I'd be getting something like 0 over 0. I didn't move at all because it's at just one point, and it didn't take any time because it's at just one point in time. And 0 over 0 doesn't make any sense, so we have to do something else. The key idea is to know how fast I'm going at a particular moment in time, take smaller and smaller increments near that moment in time. So here's an example. Let's say an object is moving, and we've got this information about where it is at each time. So here I'm going to assume time is measured in seconds and distance, or position S is measured in meters. So at the start, t equals 0, I haven't moved at all. I'm at the 0 position on whatever measuring tape I've got. And after 1 second, I've moved 5.1 meters, and so on. So we have a bunch of information. The question is, at 3 seconds, 3 seconds after it starts moving, how fast is this object going? So again, what we're going to do is take a bunch of average velocities. And those average velocities are going to be over very short time intervals near the time 3 seconds. Then we're going to use that information to sort of guess how fast it's going right at 3 seconds. And at this point, all it will be is an educated guess. We will get precise in future sections. Sorry about that. Okay, so we want intervals near 3. Here's an interval near 3, the time interval from 2 seconds to 3 seconds. If I want to compute the average velocity over that time interval, it's a change in position over change in time. So change in position is the position at the end of that interval, 23.8 meters, minus the position at the beginning, 14.3 meters, over the change in time, 3 seconds minus 2 seconds. Okay, that's pretty easy division to do. That's 9.5 meters per second. Now I want to take another small interval, an even smaller one, near 3 seconds, so 2.5 seconds to 3 seconds. How fast was the object moving in that time period? Same idea. It was going 9.4 meters per second. And so on. Right, I can compute average velocities over time intervals, getting closer and closer to right at 3 seconds. Right, so this last one covers 1/20th of a second is the elapsed time, but it's still an average velocity. Change in position over change in time. I've done a bunch of intervals moving from slightly before 3 seconds up to 3 seconds. I should also do some on the other side of 3 seconds. So we'll take the interval from 3 to 4 seconds. and I get an average velocity. From 3 to 3.5 seconds, I get an average velocity, and so on. Each time interval near 3 seconds, I'm computing the change in position over change in time. That's an average velocity, and I get some answer. All right, since my position was in meters and my time was in seconds, these speeds are in meters per second. If it was miles and hours, it would be in miles per hour. Okay, so now the question comes, the question I'm trying to answer. How fast is this object moving at t equals 3? Right at the instant when we hit 3 seconds on our clock, how fast is this thing moving? Well, if you look, as my time intervals get closer and closer to being just right at 3, as the intervals get shorter and shorter right around 3, it looks like my speeds, my average velocities, are hovering around 6 meters per second. It's possible that if I took even shorter intervals, it looks like maybe it might get a little lower, so I'm not really exactly sure, but if I were to say at t equals 3, the instantaneous velocity is around 6 meters per second, I'm fairly confident that that's correct. Notice that that is an educated guess based on these 8 time intervals, and that's really all I could do with the given data. If I had more data about times really, really close to 3 seconds, I could maybe get slightly more precise, but that's enough for now, okay? But it is only an estimate. Again, we will get precise later. So I hope this gives you an idea of how you can estimate or get close to an instantaneous speed, how fast something's moving right at a second, right at a point in time, by taking a lot of average velocities over time intervals that are very short and very close to that particular moment in time. Okay, so here's the summary. Taking average velocity, which is a rate of change, it's a change in position over change in time, average velocity over smaller and smaller intervals leads to an idea of instantaneous velocity at a point. We will get a precise definition and a precise way of doing this later. Right now, we're just taking a bunch of information and using it to get an estimate.